before you start problem solving or improving or kaizening or whatever, you need to know what kind of problem you are dealing with, because it really matters for the route and the people you will take. Hello, I'm Dom. Welcome to my channel, where we make operational excellence practical for you. And today we will be talking about sort of different forms of problem solving, improvement. If you've been following this channel, you know that I love to really make the distinction between solving a problem or doing a process improvement. Well, today we're gonna add a slight little itty bitty bit of complexity to that, which will make it easier probably for you, because we'll be dealing with, let's say, problem solving, an actual one problem, and then improvement through either eliminating a bunch of problems or redesigning the process. So stay tuned for that. Also, my friends in Sweden, you know that this one is for you. So I hope you will really pay attention and get into this way of thinking. Because what we see, it's all based on, we've got performance standards, right? You know, we love to have standards that are like input standards, demand, machine, method standards, the 4Ms. We also like to have performance standards. We know what our processes should be capable of outputting. And then, you know, there's always a bit of variation. Variation on the inputs creates variation on the outputs. So what we see is that if we have a performance standard, this is our normal performance level, what do we see in practice? You know, not every day is the same. So there is some stuff going on, but on average, we meet our performance target. Now, we would expect that this just continues, right? That would be, if we don't really mess with the inputs, the outputs should stay the same. But sometimes things happen. And performance sharply drops and then sort of continues at a bad level. Sometimes it goes down like a trend with the same end result. This is, we see basically one thing happening, right? And then our performance is just bad compared to what we had before. That gives us a big clue on how to solve it. But before we go into that, let's go through the other two scenarios as well. So we've got two processes, and you know, the size now with the variation is not per se the thing you have to focus on, but the fact that there is variation is. So in this scenario, we're aiming to improve our process. It's not that it suddenly dropped, right? Here we're just aiming to get it back. Here we want to improve our average performance level, and there's sort of two ways to do this. We can eliminate all of the bad stuff, and when we eliminate the bad stuff, so basically just say, this here we all tackle, and then we end up with a process with only the better days. That way, our performance increases. Or what we can do is we're going to really dive into the process. And we get to basically levels we have not seen before, right? Well, you could say the worst days were sort of the best days here in my example, but the whole idea is that we lifted the whole process and we also got higher than whatever performance we had before. So here in this first scenario, we focus on that drop and make sure to get that level back up. Here, we focus on a whole bunch of problems, right? A whole bunch of bad days, and by that, we move our center line up. And here we have that same end result happening. We move it up, but we do it by really looking into the way we run our process. Now, that has different ways of tackling them. I mean, in general, our OPEX, Kaizen, Lean, Six Sigma tools, they are pretty similar, right? You have to sort of make them all the time. You have to define your problem, you have to measure your process and then the causes, and then think of improvements and then make sure that they are sustained. So that system is the same, but some of the details that are super useful if you can pick them up front are coming from this. So if we have a sudden problem, then we can also assume that this here is caused by one single cause, or even one single root cause. While here, we're actually looking at a whole bunch of sort of trouble things. Now, you can say that there's a bunch of things going wrong. Quite often, what we see, and that is what I would advise you to focus on, is that we don't really control the process inputs. So our basic conditions, our 4Ms, right, they are poor. We may not have good incoming material control. We don't really know the settings. Operators learn the process in different ways. Stuff like that. Maybe the machine is in poor repair. And that is what we have to be focusing on here. If we eliminate all of those things that are just subpar, seriously subpar, then we get back to, and note that we never get better days basically than we had before, because we're just eliminating stuff that could ruin our day quite often, right? In the past, hopefully. But the average level goes up. Now here we do go to a higher level. So there we really want to understand the process. We really want to know which inputs do we need to change. We probably want to change them 4Ms. So we get into process re-engineering or process redesign. Anyway, we're going to rethink the way we work. That too has a big influence on what type of improvement routes we're going to pick. See, for this, right, so if we're looking for one cause, and probably even just the one root cause, then what we really need to know is what happened there. And we can do it with a timeline, we can do it with event mapping, but the basic tool I would say you should always use is just the questions, right? The 5 W's and 2 H's. The what happened, when did it happen, who was involved, why, how much, how did it happen. So where did that problem occur? Make sure you get a very good problem description and then put a good root cause analysis on that. So those are the key tools for solving this type of problem. And what I would advise you is to go and check out my 6-step problem solving method. Of course, you can use an A3 or an 8D. They are perfectly fine problem solving tools as well. But if you want my template, go and download it through the link. And it will take you through that process of, we're going to really define what happened, because just knowing what happened, that'll solve, well, over 50%, maybe even 80% of our problem will be solved by that, but not the root yet. And as soon as we do that, we'll put some countermeasures in place. So there's a couple of steps that here you don't really do. You don't put quick countermeasures in place, right? Not temporary controls. This has been happening for months, years maybe. No temporary stuff. Here, as soon as we really know what happened, you've got some big savings to make by just immediately putting temporary controls in there. Then we'll check what happened. Here in this method, we will also be going to check the escape point, right? So you basically, and that's why you sort of have 2 root causes here, because you've got a cause of why did this happen and a cause of why didn't we see it before. Those are the 2 problems. And we make sure we get to the root cause for both of them, fix it. Because we can assume that there is just one actual cause to this, one thing changed. Here there will be plenty of causes and plenty of root causes. Now maybe all of these problems, they stem from the same root cause. Who knows? But let's not make that assumption. So what we do here is we're going to really focus on those basic conditions first. And that honestly is something we don't care too much about here, and also not that much over there. So first we want to know, what are those problems? And for that, we have a nice little tool. You probably know it. We take Mr. Pareto's diagram, where we take a whole bunch of failure modes, issue modes, and we check which ones come up the most. What are the main causes that lead to poor performance? Because there's probably 10 possible causes here that all happen sometimes on a Blue Monday, but a few of them, they will have the most impact. We'll find those with a Pareto and then really dive into how can we make sure that those causes get eliminated. And also, because we know that it's probably a case of poor standards control, poor input control, we're going to focus a bit more on process control, but specifically on the 5 questions for 0 defects. That is a system that you, by the way, can also find in that same problem-solving file. The reason is that at the end of these routes, when you make new standards, you want to use this on any new standard. But specifically when you're doing this type of improvement, you want to be using it on any relevant standard. You want to be checking the known conditions for how good are their standards. The 5 questions for zero defects, they are like, how easy is it to learn this standard or to set this standard, and how stable is it when the process starts, how easy can I detect it, stuff like that. So it's not about, is the standard the right one? We sort of assume that when the process was set up, people have been thinking about it, and this is the right standard. We are more concerned about that this is a standard that in practice is very difficult to maintain. That's what this tool identifies. So that's why it is pretty unique in the analysis phases to specifically this one. As I said, when you make new standards, you always want to use this tool. So go and download that template because they are in there. Then when we think about, we want to get a different outcome, really move the needle, move the process. So what then do we need? Well, if we want to move things, we're not that interested in causes and root causes and stuff like that, because we're basically not targeting any problems. We want to really understand the process. There are many ways to do it, but a couple of the most important ones. The cause and effect diagram and design of experiments. As I said, there are a whole bunch of different tools, and there's a whole bunch of statistical tools that also come into play when you go into this type of redesigning. There is a bit more brainstorming that goes on here, but a couple of the tools that are similar to what you might see here, that cause and effect diagram, or quite specific just for that, I wanted to highlight. See, the cause and effect diagram, when you make it, it just looks the same. It's a fishbone, right? It is a fishbone diagram, but it is a fishbone that is not targeted at a specific problem, which especially here, when you use the fishbone, you want to know exactly what is causing that problem. So not anything that may or may not happen. No, we want effects that cause the problem and that are true at the moment. No theoretical stuff, no, this might be optimized, but it has been like this already for years. So when it was true here and true here, it's not interesting in our fishbone here. When it was not true here, but it is true here, oh, those are interesting causes, potential causes. Now, that cause and effect diagram is interested in all the things that happened here. And that's why the way you use it looks like a fishbone, but the goal is different. That's why I wanted to call it out here. You're gonna go for your output result, and you're going to be stating all kinds of causes that have an influence on our affected output. And you're gonna check how strong is that link. Now, one of the ways to do that in a very strong statistical way is by designed experiments. Right? We're not going to go into those in this video, but in a DOE, what you do is you take a few parameters, usually something like 3 or 4 or so, that you really expect to have a good high impact on your affected output. And then you're going to stress test them. You're going to take them outside of the normal operational ranges, a bit in the middle, but you're going to really do a couple of trials in a nicely designed trial experiment. And by that, you're going to get process knowledge that you can use to go to a more stable or a more performing output. Yes, there are plenty more tools. There are also more tools here, but these are the important things that I want you to take into your way of thinking about problem solving and improving. So we've got our basic problem solving. A problem happened. We expect one big change that has one root cause. So we want to know exactly what happened and why that happened and fix that, right? Then we want to improve our process by eliminating a bunch of problems that we right now have, right? The bad days. That means we're going to focus mainly on all kinds of process stability. And the first thing to focus on is the basic conditions. So stuff we already know should be in place, but when you check it in practice, it's not. Yes, you can also improve certain things, but this just gives you the biggest bang for buck. That's why I advise you to focus on this word. This is sort of advanced problem solving. We're solving problems, just a whole bunch of them. And for that, you need to choose, you need to focus on maintaining those basic conditions. And when you really want to move the process, you need to better understand all of the effects, how the inputs specifically affect the output. Can we get to a more optimal set of inputs? Now, this you do not want to do when you still have a lot of variance, because this is generally easier. It would be a waste to really set a perfect temperature, pressure, time, and then just see that half of your operators are setting their own things, not following basic conditions. So this comes next. This is real process improvement, and for that we have a whole bunch of tools that help us understand the process. Now, where are these the same? Any of these, they start by forming a good target, a goal, and a team. So step one for all of these is get a team together. Step two for all of these is to really look at what is my problem or process that I want to solve or improve. Then we get mostly into these. Then step somewhere, right, 4, 5, 6, depending a bit on your routes, somewhere there, near about 2/3 of the route, there are going to be countermeasures. Because all of them, they're going to make a change to how we do things around here, the procedures, basically. So we've got countermeasures to solve the root cause of this one problem. We've got countermeasures to eliminate those things and strengthen the basic conditions, or we've got countermeasures, process improvements to really go to a new performance level. And those all have to be managed sort of like a process, project, sort of, right? And then all of them will also have the validate and sustain, right? So you want to know, did my countermeasures actually solve the problem or improve the process? And here those 5 questions to 0 defects come back into the play as well. Those new standards, they need to be good. They don't just need to be the right standard. They also need to be easy to set, easy to keep, easy to spot when things go wrong. So use those questions again and put it into a good system of process control, or put it into the cycle of control, basically. But before you do that, you need to make sure that the quality of the standard is good. And you do that for all of them. But this type of focusing on basic conditions is the only one where you already do it in step, 2 or so. It depends on how you set up your route, but a very early step. This is basically your next step after you have decided which issues you're going to tackle. So that I wanted to give you as a little Christmas present is how you think about the different ways to improve performance. One problem, a series of problems that we're going to be solving so that performance improves, or we're going to be redesigning, re-engineering our process. I hope that triggered thought for you. Let me know in the comments. Do you actually have several improvement routes in your organization? I'd love to hear. Is it more than 3? Less than 3? How would you set them up? Love to hear such comments, because I want this channel to be sharing. Honestly, I think we don't share enough yet in our community. So come on, write some comments. For now, I wish you a Merry Christmas, and I hope to see you with a lot of energy next year. And as always, don't forget to also enjoy the continuous improvement journey.